Hi everyone, we are on chapter 8 still, and I wanted to let you know, I know you can't see me too well up in the upper left hand corner, but this is such a great map that I wanted to show it to you. We're talking about occluded fronts now. We'll explain a lot more about them soon, but I wanted to show you some history, and this map on the left is from 1887. I believe the map on the right, is from 1893. Remarkable things. One is Europe, one is the United States, obviously. And as you see, there are no fronts on there. There are no triangular lines. There are no semicircles for warm fronts. There's no stationary fronts at all. This is before frontal theory was invented. So all you have on here are black markings on the European for pressure. And on the Americans, which is a little bit more evolved for the time, were black markings for pressure and red markings for temperature, because they knew the two things worked together. But nobody had fronts, so let's talk about some of the history behind it and how fronts evolved. 1800s, we were getting links between pressure and temperature and storms. And people were starting to put the observations together with some data. 1910s, a group out of Norway that was trained in Germany was looking at surface observations only for pressure and temperature, and noting that in the middle to upper latitudes, 40 degrees latitude to about 65 degree latitudes, that there were consistent observations of temperature and pressure. And in particular, the temperatures seemed to go, first cold would come, then cool would come with precipitation, then colder would come with more precipitation. So they started to really look at that and apply mathematics to it. By World War I, they had vortex research for ocean eddies that they were starting to apply to fluids and air atmospheres, suggesting rotational storm patterns. It was a big leap. And during World War I, they started to talk about fronts, because so much of the world was obsessed with conflicting masses and battlefronts. So we actually get our frontal theory directly from World War I. Just to go over the types of air masses: maritime, continental, and the source regions: Arctic, polar, tropical. And the types of fronts in this front theory, which was dramatic. They had to invent air masses and invent frontal theory for stationary fronts, cold fronts, warm fronts. There was this whole new theory of forced frontal lifting. In other words, the warm air mass can lift itself over the Cadillac, or the Cadillac can barge into the warm air mass and lift the warm air mass. This had never been introduced before. Now we're going to talk about occluded fronts. And occluded fronts are over here. You know the stationary, the cold, the warm, and how they look on a map. Occluded fronts are different. Occluded means shut off or secretive, like an occult, which is a magical, mystical phenomena. In this case, the secret is what happens to the warm air. It's called the warm sector, and it is the energy, the convective energy for a fierce storm. So we're talking now about cyclones being formed from occluded fronts. In an occluded front, there are two fronts that are battling it out. So we're not just talking two air masses here. We're talking two fronts here. Let me go over it. First, you have a warm front. Remember, the Volkswagens went over the cold front Cadillac? First, you have a warm front that is being chased by a cold front. So we have many air masses here. We have a cold air mass, a warm air mass, a cold air mass, a warm air mass. A warm front is being chased by a cold front. What I wanted to say here is that, yes, I have cold air being topped by warm air on the warm front, and I have warm air left over moving on top, and I have a cold front here where I have warm air being kicked up by cold high density air. The point being, I have a big warm sector in here between the warm front and the cold front. The occlusion, the secret, is what happens to this warm sector. It disappears and it fuels a fierce storm. We're going to talk about two different types of occluded fronts. One is a cold occlusion and one is a warm occlusion. In this video, we're going to talk about the cold occlusion. Next video, warm occlusion. The cold occlusion is a slow, warm front being chased by a faster, very cold front. All right? So let's look at it this way. Here's your warm front and your stable atmosphere because you have a warm lid that is preventing any mass from moving above it and being buoyant. Okay, so you have a stable atmosphere here with this warm front. And the cold occluded front says, I don't care if it's stable. I have a very cold air mass, which is very dense, and it is just going to kick your warm front up. So it is the Cadillac Escalade cold front on steroids that's going to kick up an entire stable warm front. Now, the Norwegians who invented this theory did not believe that this could exist. They theorized it, but they said you're never going to see it in practice because this is just too stable. But we're going to tell you about it anyway. And this is A, the start, the timeline, B, in the middle of the timeline, and C, toward the end of the timeline for the occlusion. When we start the timeline, we start at A with a warm front, the warm sector, and the cold front chasing it. And that's what we have here. We have this cold front chasing down this warm front. When we get to B, in here, the cold front caught up. The cold front caught up with the warm front. The occluded front is now a combination of the blue cold front and the red warm front to make a purple sign. Some maps, especially in newspapers early, never had color, so they also used a shape sign, and they put together the triangles and the circles as well. Now you might say, well, that's a stationary front, but this is a purple stationary front. And another way of looking at it, if you were in a newspaper in the 1900s and it was black and white, the stationary fronts were going to be straight because the winds were going to be going on either side. They were very even. And the occluded fronts have a curve to them that is the force of the coldest air mass that is pushing the curve. So I'm not saying it's a beautiful system, but you now see it as purple, so you know it's an occluded front. It's kind of a mystical, kind of a magical purple front. So it serves two purposes in the meaning of the occult, the occluded front, and also the blue and red mixed together to make purple. I will tell you that this was theoretically impossible in the 1920s, but guess what? In the 1990s, data started to come in from the upper levels that showed that in the Great Lakes, this does happen. Cold occluded fronts do happen. The warm sector in a cold occluded front actually moves up into the upper levels. So that it's no longer seen at the surface, so it seems kind of secretive. It's no longer there. In the 1920s, when this was all published, nobody was doing upper level research, so that if this moved up into the upper level atmosphere, it effectively was magically gone. When this warm air moves up into the upper levels, of course, it has a lot more energy, and it can really boost convection and condensation. And so you see the anvil clouds up toward the stratosphere. So this can produce thunderstorms. It can produce thunder snow in these occluded front storms that are very powerful. In here, I think I've gone over all this, and I think I have. What I will say on this is this, that the theory of cold occluded fronts that is now coming true is seeing that this 100-year-old theory, this frontal theory, needs some revision. So experiments are being done on the cold, well, I would say analyses are being done on the cold occluded fronts to try to revise this formula a bit more. It's known as the polar front formula, the polar front theory, and we'll get into that very soon. What we find is that the more stable the very cold air mass, the higher the likelihood that it can kick the warm front up. So the colder the cold front, the more stability it has to kick the warm front up. Now, it's not just temperature that predicts stability. Let's go into, I think I have a slide. Yes, so I have a next slide that there are other things that predict stability of this cold front. And some of the things that predict stability are if it's windless or calm, because remember that predicts a stable atmosphere. Remember, the fog can really only exist where there's no wind in the atmosphere. If you have fog, or if you have stratus clouds in your very cold front, that is an indication that it is a very stable front that might be able to kick up a warm front. If you do have precipitation, it should be steady precipitation, not precipitation that rushes in and rushes out. This should be a steady, showery precipitation that would indicate a very stable air mass that might just be able to lift up the entire cold front. Now, very important. Where is the occluded front line? The occluded front line is actually in front of the warm front that has lifted. So one of the things you're going to think about is where on the surface this occluded front line is. It is in front of your now elevated warm front, and there is precipitation continuously from the warm front back through the cold front. So it's an occluded front lasts a long time. It leads to flooding often. I mentioned this before. Cold occluded fronts now have better upper level modeling and data. So we're starting to find it particularly in the Great Lakes. Let's go on to warm occluded fronts next.